Alright, so over the next couple classes, what we're going to go over is the most important chapters, which are really chapters 3, 4, 5, and I think 6 out of the mechanical code as far as passing your journeyman's exam. We're going to go over those and make sure that you understand what kind of questions are on the test and what they like to ask questions about. I've taken multiple of these tests. I've taken the HVAC, I've taken the plumbing, I've taken the gas, and you kind of get a feel for the kind of questions they ask on the test and what they're worried about. And most of it is safety related stuff, access related stuff, things of that nature. So that is what we are going to talk about in most detail. I'm not going to go over everything in the code. I'm going to read through most of the chapters verbatim just to make sure that we highlight important sections, but I'm not going to go through everything. I'm going to go through most of the stuff that's going to help you pass the journeyman's. If there's any specific questions on code issues, you're more than welcome to get a hold of me or to talk to your local code official if you've got questions out of the code book that aren't related to what's really on your journeyman's. Other than that, it's just to highlight and go over stuff that's on your exam. So before I even do that, let's talk taking your exam. So most of the stuff on the exam is going to be straight out of the code book. I mean, just straight out of the code book, which means that if you can find the word or the sentence that matches what's on the question, you'll be good answering it. So the quizzes that I put up in the practice exams go over that pretty good. For example, if we look at the first mechanical code quiz that I put up, they'll ask something. Let's pick one. Trying to find a really good example here. So, on definitions on chapter 2, I'm not going over chapter 2 because you should be able to go through chapter 2 and see definitions, but you want to read through all the definitions once because the code will say, that which enables a device, appliance, or equipment to be directly reached without requiring the removal or movement of any panel, door, or similar obstruction. So that would be ready access, right? So, basically they just give you the whole definition of ready access and expect you to be able to find that answer. So a lot of the questions on the test are like that. You should be able to find the exact wording where the exact answer is on the exam without having to look too much. The only exceptions to that are things that ask about something you need to be able to do math on. So we're going to go over chapter 3 and on structural safety, but the edge of a bored hole shall not be closed. Well, no, that's exact wording. The maximum size hole in a 2x8 joist should be blank, right? Well, to figure that answer out, you're going to need to know that a 2x8 joist is really 7.5 inches, so you need to understand that the true depth isn't the actual depth, right? And then you need to know what percentage the code allows you to drill in a 2x8 joist. So you do have to do a little bit of math for something like that, which I'll give you the answer for, and we'll go over. But the majority of the questions are just basically find the missing word in the sentence or find the word that matches the sentence. You should be able to see the exact answer without a doubt. So when you're taking the test, I highly encourage you to go through the book and find as many of the exact answers as you can. Unless you're 110% sure you're right, get good at going through the code, finding the exact wording, and answering it so that you have at least 70% of those questions you understand you did not get wrong. You're just 100% sure that you did not get them wrong. And once you've done as many as you can like that, you can guess on the rest. And it's a multiple choice test, so just guess on the rest. It's stupid to not answer a question unless you just run out of time, which is possible. But unless you just run out of time, try to take a wild guess at it. Usually on multiple choice quizzes, at least 2 of the answers don't really make any sense. So if you go through and you try to answer them, you should at least get a few extras like that, even if it's difficult for you to find the answer. The other tip is to make sure that you understand the layout of the code. So you should understand what bits are in each chapter. So, I mean, as soon as you see a question, you should be able to say, oh, I know what chapter that's in. It should be very obvious. The only exception maybe being the stuff that's in definitions. Maybe you won't readily recognize that it's a definition, or maybe some of the stuff in chapter 3 can be tricky because it kind of incorporates stuff from all the chapters. But for the most part, you should be able to say, oh, I know that this is in this chapter, and be able to dig through the chapter at least. So what I'm going to go over is, again, we're going to start with chapter 3 in this class, and I'm going to go through the most relevant points of chapter 3. You can see that what I have up is not laid out like your code book. I don't really have a way to pull up the code on the computer in a way that it's exactly like the book. So this is printed off of UpCodes. As a matter of fact, let me go through that real quick before we continue. If we go to let me see if I can pull up a browser page here. Just a second. Where I get my code information, because to be honest with you, it's pretty much unnecessary as far as code books go to really purchase one anymore. It's not a bad idea to purchase them, and you should probably have bought at least one code and one commentary at least once in your career. At least once you should have bought a code and commentary so that it helps you understand. But after that, really it's better to just pull the codes up online, because you can find everything relatively quickly. So what I use right now is UpCodes. They used to be on ICC's website, and maybe it'll go back to that at some point. But basically, they always give you the option of getting a code online anymore. So there's really no reason to purchase one. Pretty much since 2012, you've been able to find them online. So if you just search Virginia International whatever code, mechanical code, or whatever code you're looking for, residential code, mechanical code, building code, bring that up. And I'm on Bing right now, but it's the same thing on Google. You'll see the UpCodes come up, up.codes. If you go on their website, it's got all the codes, and you can see here that you can go through all the chapters. You can actually just go up here and print. You can print the chapter, and that's what I've done here. You can even print it so you can take it with you. You can print it to your printer. You used to never be able to do that without buying the code, but you can even print them off of UpCodes. The only thing you can't do without paying for it, without actually making an account and buying it, is search and things like that. You'll have to know where to look. But after we're done with this, you guys should be able to search the code pretty fast. I've never really had a problem finding many things in the code. It's really not that bad as long as you know what you're looking for. So that's kind of the goal, is to get you guys good at just opening the code book and knowing where to find the information. Because that's the other thing, is even in the trade, it's really not important if you're a tradesman to know every code in the code book. What's more important is to remember things that you need to double check. You know what I mean? How far does a clean out have to be on a grease duct? I think it's 20 feet horizontal. I'm almost positive it is. But if I didn't know, I'd know where to look very quick, and I could find that information easily. And that's what you want to be able to do. You want to be able to find information quickly and easily to make sure that you're code compliant when you're doing any work. All right. With all that being said, let's actually dig into chapter 3. And we'll highlight the relevant portions. So chapter 3 is general regulations. It's basically the catch-all chapter on the code book. So, you know, random stuff's going to be in here essentially. What? Why isn't it letting me highlight text? It's gonna annoy me. Huh. The text recognition is not working, so we'll just have to highlight it the old school way. All right, so anyway, chapter 3 general regulations has just a lot of random stuff in it. Mostly stuff about equipment and things like that is going to be important, but let's just look through it. Oh, one more thing. What I'm going to be going through is the actual Virginia code because I printed it from the Virginia codes. That means there could be some differences between the Virginia code and the actual mechanical code. If you know those differences between the Virginia and the international, obviously if you're in Virginia, the Virginia one's the more important. So that's the other good reason to look up the codes online all the time, is to make sure you're seeing the Virginia code without the changes. If you're using the international code, then you want to have read through the VA USBC a little bit to see what the changes are so that you know what is different between Virginia and the international code. But if you buy a code and most of your work is in Virginia, I highly recommend that you look at or buy a copy of the actual Virginia code. You can get that from International Code Council's website, and if you go to VA USBC stuff, they give you links to get the actual Virginia codes. That's up to you guys, but that's obviously more recommended. All right, so chapter governs the approval and installation of all equipment and appliances that comprise parts of a building mechanical system regulated by this code in accordance with section 101.2, which is just administration. Heating, ventilation, and air conditioning systems of all structures need to be designed for efficient energy utilization in accordance with the Energy Conservation Code. So that means you need to understand what's in the Energy Conservation Code too, because some of those things may apply to what's in this code. All lengths of pipe and tubing in a mechanical system has to bear the identification of the manufacturer. Believe it or not, I've been busting on that on jobs before. If you buy like specialty fittings and things like that, like there's some fittings, PVC fittings and stuff that's fabricated, and they don't put anything on there that bears the identification of the manufacturer. You can't use a fitting if it doesn't bear some kind of identification for the manufacturer or any pipe. It has to be UL listed and meet standards. So if you don't know where it was made, you can't prove that it meets a standard. Plastic pipe components have to conform to NSF 14. Everything has to be tested by a third-party agency. Fuel gas appliances and equipment have to be done in accordance with the International Fuel Gas Code. All appliances have to be listed and labeled for the application in which they are installed and used unless otherwise approved. So this is important. All appliances have to be listed and labeled, which basically means a company like Underwriters Laboratory or somebody else has tested the equipment for the situation they're installed in. So, an example of this might be you can't put an indoor tankless water heater outside, right? Because it's not listed and labeled for outdoor use. Anything like that. You can't use something in a way that it wasn't intended. Labeling has to meet these requirements. So what they mean by labeling is an approved agency tests a representative sample of the equipment and appliances being labeled to the relevant standard or standards. The approved agency has to maintain a record of all the tests performed, and the record has to provide sufficient detail to verify compliance. The approved agency has to periodically perform an inspection, which shall be in plant if necessary, of the mechanical equipment and appliances to be labeled. The inspection has to verify that the labeled equipment and appliances are representative of the mechanical equipment and appliances tested. The agency has to be independent, and the agency has to have adequate equipment to perform the required tests. And an approved agency shall employ experienced experienced personnel in educating. And what all this boils down to is that when you get the equipment and it says it's UL listed or whatever, some agency had to have tested that equipment, and that's why it's so expensive. There's some things that work for certain situations, but they're not specifically listed for that situation just because it takes so much money to get approved. Some manufacturers don't bother getting things approved for certain situations. The best example I can think of is stuff in a plenum. Sometimes something could be plenum rated, but it's not listed to be used. It's not listed and labeled for plenum use. It doesn't have that label because maybe only certain types of it do, or something like that. There's maybe some situations where it can and it can't. So they never get it listed for that. Things like that. But anyway, everything has to be listed and labeled. This is one that I actually don't see enforced label information all the time, but I've seen equipment that doesn't come with all the necessary label information. And it's amazing to me that people don't get busted on it because I'm telling you, every once in a while you'll see equipment that's not properly labeled. But a permanent factory applied nameplate has to be affixed to appliances in which illegible lettering bear the manufacturer's name or trademark, the model number, serial number, and the seal or mark of the approved agency that tested it. The label shall include the following: for electrical equipment and appliances. On the equipment, you have to be able to read the electrical rating in volts, amps, and the motor phase, the identification of the individual electrical components in volts, amps, or watts, and the motor phase, and the BTU output and the required clearances. For absorption units, you have to be able to read the hourly rating in BTUs, the minimum hourly rating for units having step or automatic modulating controls, types of fuel, types of refrigerant, cooling capacity in BTUs, and required clearances. For fuel burning units, hourly rating in BTUs, the type of fuel approved for use with the appliance, and the required clearances. And for electric comfort heating appliances, the electric rating in volts, amps, and phase, BTU output, individual marking for each electrical component in amps or watts, volts, and phase, and required clearances from combustibles. All that stuff is supposed to be on a label on the equipment. So it's not a ton, but every once in a while you'll get a fuel burning appliance that doesn't have all the label information or something like that. I can't think of a specific example right now, but I have seen it. It doesn't have all the required information on it. All right, electrical wiring connections and controls are in accordance with NFPA 70. Okay, so that's going to be a difference between the codes if I remember right. The international code says in accordance with the International Electrical Code, or it used to, but Virginia is NFPA 70. NFPA 70 is your NEC, your National Electrical Code. All right, plumbing connections have to conform to the International Plumbing Code. Fuel-fired appliances shall be designed for the type of fuel in which they're connected. I mean, that should be pretty much self-explanatory. Where vibration of isolation of equipment and appliances and performed and approved means of supplemental restraint shall be used to support and restrain. Defective material or parts shall be replaced or repaired in such manner as to preserve the original approval or listing. So when you repair an appliance, you have to make sure that your repairs will preserve the original listing, which kind of boils down to you're supposed to really use OEM parts. There are situations where the replacement part, even if it's not OEM, would preserve the original approval listing, but there's sometimes it won't. So that's why you get factory reps sometimes that'll come out and say they can't make a certain change to the equipment because it would then no longer be listed for that particular reason, or it changes how the equipment functions, so they can't do it. I've had that happen before. On like a Train RTU that had a reversing contactor. We could have removed it, didn't really need it anymore, but technically that would change how it's listed, so you can't just delete that component. You have to, wind resistance, the mechanical appliances and support have to be installed to resist the wind. Flood hazard and flood hazard areas, the components need to be protected from flooding so that they don't enter or accumulate in parts. Buildings and structures have to be rodent proofed, so you got to seal all your openings, you got to caulk all your joints. That's what makes it so they can fail you if you don't caulk where your line set goes outside or something like that. And where earthquake loads are applicable, you have to have mechanical system supports designed and installed for the seismic forces in accordance with the International Building Code. Alright, so that's the first section of every chapter is basically just stuff like that. So stuff really you probably don't even need to bother reading, because most of this first chapter is just as a matter of fact, I'm going to delete pretty much all my highlights here because none of these are important. The whole first section isn't really a big deal. Alright, it just explains stuff. It's good to read through at least once, but usually everything, all the meat of the chapter gets started in the second section. So section 302, protection of structure. Pretty much this whole section is important, but we're going to highlight the most important parts. Alright, this is all about what you can do as far as cutting holes in wood members of a building or anything like that. Alright, so the building or structure shall not be weakened by the installation of mechanical systems. Where floors, walls, ceilings, or any other portion of the building or structure are required to be altered or replaced in the process of installing or repairing any system, the building or structure shall be left in a safe structural condition in accordance with the building code. Penetrations of floor ceiling assemblies required to have a fire resistance rating shall be protected in accordance with Chapter 7 of the Building Code. Alright, I'm going to highlight this because it's important. I highly recommend that you go through Chapter 7 of the Building Code at some point, especially since you guys do mechanical work, and we have things that we need like fire dampers. Being able to understand fire resistance assemblies and floor ceiling assemblies and where you need fire dampers and where you need smoke dampers and things like that are extremely important. I am sure that I will have a video up on that at some point, but maybe not before you take your final quiz. None of those, or final test, none of the things are important for your test, but this is still important to understand. So watch for that to be up, a class on fire dampers and fire smoke dampers and fire rated assemblies and stuff like that. But in the meantime, I urge you to read Chapter 7 of the Building Code at some point. Alright, cutting, notching, and boring in wood framing. This is the most relevant section. 302.3. All the stuff in 302.3 is the meat of what you need to know. Alright, 302.3.1, joist notching. All of this is important. Notches on the ends of joists shall not exceed 1/4 of the joist depth. Holes bored in joist shall not be within 2 inches of the top or bottom of the joist, and the diameter of any such hole shall not exceed 1/3 the depth of the joist. Notches in the top or bottom of joists shall not exceed 1/6 of the depth and shall not be located in the middle third of the span. Alright, so let's dissect that a little bit. Let me open up another. Let me open up a blank PDF here. Make sure it's up. Alright. Let's dissect this. So if we have a wood joist, alright. So let me make a scale here. I should have prepped for this, but let's do 1.5 inches equals a foot. So if we do, let's just do a 1x12. Let's do a 1x12 joist to make it easy. $1.5. No. The heck? Why isn't changing? This is gonna drive me nuts. do. All right. Bluebeam is being a pain in the ass, I guess. So let's, if we have a 1x12 joist, all right, we're just gonna make this 1x12. Actually, what is it? 1x12 is 11.5, right? It gets weird once you get that big. You know what? Let's just, as a matter of fact, let me just go to a 1x10 because I'm almost certain that that's 9.5 inches. So if we have a 1x10, right? The first thing to understand is that a 1x10 is not 10 inches. It's closer to 9.5. And this changes for every stud size. So you're just going to have to kind of know that that's what's going on. But for now, oh my God. Why can't I get it to go to 10? I think it'll be easier if you can actually see the dimensions. All right. Be snapping. Computer programs, man, are very irritating sometimes. It should let me manually set these numbers, but it's not behaving. Alright, so we got a 1x10. It's 9.5 inches, right? Notches, alright? Notches on the end of joists shall not exceed 1/4 of the joist depth. So they are actually talking about the end of the joist here. So if we were to make a notch, alright, in the end of the joist, if we do, make sure our calculator is up, if we do 1 divided by 4, right? Because it says 1/4. So if you don't know how to do decimals, I highly suggest you pay attention. It said it cannot exceed 1/4 of the joist depth. So 1/4 of the depth would be 0.25, right? 25% of the joist depth. We multiply that by 9.5, all right? For 1x10, or 2x10 rather, that would be 2.375 inches. Okay, so if we measure this, right, it should not exceed 3.75 inches. Right now, that notch I just drew was 3 1/4, so it is over 2.375 inches, right? So that wouldn't work. And since it's not letting me input values, I can't probably draw it perfect. So maybe we'll just have to write down the numbers. Is it going to let me input values now? No, it's not. It's not giving me the highlight properties. Oh, because it's on that. That's what it's doing. Alright. Since it's not going to let me do it, I'm just going to input the dimensions. So anyway, this cannot be more than 2.375 if you notch the end of the joist on a 2x10, right? Now, the next thing that it asks you about, or that it tells you, is that holes bored in joist cannot be within 2 inches of the top or bottom. So we can draw a little circle here, right, for a hole in the joist. And that dimension, okay, this cannot be closer than 2 inches from the top or bottom of the joist. And we're not going to be able to read that too. Can I fix that? Yeah. No more than 2 inches. Okay. or no closer than 2 inches to the top or bottom. If it's closer than 2 inches at the top or bottom when you bore a hole, then it would be considered a notch instead of a hole. So that means that the hole, if it's drilled within 2 inches, is going to have to meet the requirements for a notch and not the requirements of a hole. You know what I'll do is I'll delete this 2.375 and we'll just say 1/4 the depth. We'll actually write the rules instead of writing the numbers for the 2x10. Well, and then we can put for this 2x10, I'll put it in parentheses, 2.375. Maybe I'll upload this when I'm done in case it might help. Alright, so notches in the ends, no more than 1/4 the depth. Holes not within 2 inches. Then it says that the diameter of any such hole shall not exceed 1/3 of the joist depth. So the dimension of this hole, alright, cannot be more than 1/3, or in this case 9.5 divided by 3, right? 9.5 divided by 3 try this one more time. 9.5 divided by 3 would be 3.16 inches. So 3.16, and this is on a 2x10. inches. There. Alright, so the hole cannot be bigger than 1/3 of the joist depth. It can't be within 2 inches. And then the last thing is notches in the top or bottom of the joist shall not exceed 1/6 of the depth and shall not be located in the middle third of the span. Okay, so that means if you want to do a notch in the top or bottom, alright, this notch cannot be more than 1/6 of it. So no more than 1/6. So again, 1 divided by 6 gives us 0.1666, right? 1.167. That times 9.5 will tell us the biggest hole or notch we can make, and that's 1.58 inches deep. Alright, so 1.58. And you know what? I put this dimension wrong. It's not this way, right? It's this way. Alright, so it can't be more than 1/6 deep, or 1.58 inches if this was a 2x10. Alright, and it cannot be located in the middle third. So, you know, if this joist, let's just take a measurement here on how long we're pretending this joist is. If this joist is 2'7", which would be really short for a joist, right? Usually they're 10 foot. As a matter of fact, let's just make up a number. Let's say this thing is 12 foot long, okay? Let's pretend that this joist is 12 foot long. So if it's 12 feet long, we cannot be located in the middle third. So if we cut this thing into threes, right? We draw an imaginary line here. This would be 4 foot over. We draw an imaginary line here. This would be 4 foot over, right? Then we cannot notch in this middle third section. Alright? This middle third section, you can have holes, but you cannot have notches. Alright? So this is the middle third. No notches in middle 1/3. Okay? And those are all your rules for joists. And that's what you need to know when it comes to joists. Alright? So, that's the whole idea there. Someone just texted me, 2x10 is 9 1/4. So, you know what? For the hell of it, let's fix all our measurements. I knew I should have looked it up. It's different for everything, right? So, 9 1/4, 2x10 is actually 9 1/4. So, let's do all our math again. It'll be good practice to do our math, right? So you measure the 2x10, it's actually 9 1/4 inches deep. You do 1 divided by 4 for the notch times 9.25, right? 9 1/4, 9.25. That would be 2.3125. All right. Dadgummit. Let me move this number somehow. There we go. Quarter depth. That makes it looks like it's over there. I don't know. We'll have to leave it there. Alright, quarter depth, not more than 2.3125. Middle third, so 1/3. 1 divided by 3, alright, is 0.333 times 9.25, which is the depth of our joist, and that'll give us 3.08. Alright, 1/6, again, 1 divided by 6 equals 0.166 times 9.25, the depth of our joist, and that's 1.54. You can see it didn't really make that big of a difference, right? No, very rarely is an inspector going to get up and say, oh, this, obviously 1.54 or 1.58, you're going to say, I can't notch it more than 1.5 inches, right? 3.08, 1/3, you're going to say, I can't notch it more than 3 inches. Quarter of the depth, 3.125, you're going to say no more than 2 3/8, and really 2 3/8 would be a little bit over. You probably say 2 1/4 if you're smart, right? But you probably still get by with 2 3/8. As long as you're being somewhat careful and not making the joist Swiss cheese or being egregious with how it is notched or anything, then you should be okay. Alright, but that is how you trying to find a good spot to put these numbers. Try right there. Alright, so that's what you're looking at on joists. And you can see it kind of takes a little bit to get your head right on what these numbers are. But that's what you need to be able to take out of this. You need to be able to read this, understand it, and be able to tell me, okay, how big of a hole can I make? It's the important part. You need to be able to do this out of cutting, notching, and boring. As a matter of fact, I'll go ahead and say here that I think mechanical guys are the worst in understanding structural safety. Guys have a tendency to need to run duct work in a building and just take a chainsaw to the whole damn structure. And you really need to be careful about doing that, because it's usually the mechanical guy that cuts through a joist, setting an RTU or something, or really messes up the structure. And sometimes you have to, and you need to get an engineer, and you need to figure out how to work around these code issues. But you need to know when, hey, I need to design something to fix this, or I need to get someone to design something so I can do my work, because I'm going to exceed what the code allows me to do in this structure. And it's mostly residential oriented, right? You still get some wood commercial buildings, but most of this information is kind of residential oriented. But you need to understand it. And then when you get into bigger buildings, you'll kind of know what pieces are important, like joists or I-beams are important, and you need to understand that. All right, so that is joists. And just so you know, this does not, we're not talking about engineered wood joists. That's a whole separate thing. This is actual 2 by whatever 8 lumber, 2 by whatever lumber, as a joist, not the newer engineered stuff you see in houses these days. That is by manufacturer's instructions. All right, stud cutting and notching. All right, this is the most often one people get popped on. Stud cutting and notching. In exterior walls and bearing partitions, a wood stud shall not be cut or notched in excess of 25% of its depth. In non-bearing partitions that do not support loads other than the weight of the partition, that a stud shall not be cut or notched in excess of 40% of its depth. So the key words are here: in exterior walls and bearing partitions, cut or notched, not cut or notched in excess of 25%. All right. In non-bearing partitions, a stud shall not be cut or notched in excess of 40% of its depth. So, bearing walls support the structure. So any outside wall is always a load-bearing wall, period. All right. The other walls that might be load-bearing walls are generally walls that run perpendicular, so at a 45 or at a 90-degree angle, at a 90-degree angle with joists or roof trusses. So a really easy way to tell it's a bearing partition is if you have a set of joists that come over, right? If we have a wall, let me just go ahead and draw a wall, right? If we have an outside wall, right? And then we have another wall. Dang it. All right, and then we have another wall. Say there were joists across it. So you had a joist here, right, that runs along this wall. And then if you've ever seen it, if you've ever paid attention in a building that was being built, another joist comes this way and they sit across the same wall. So when you see that, when you see this joist spans from this wall to this wall, and this joist spans from this wall to this wall, this is going to be a bearing wall. All right, so that's an easy way to tell that you have a bearing wall. Now, sometimes a wall can be bearing when it's not in that situation. It all depends on how the building was designed. So in general, unless I know better, I always assume that any walls that run at a 90-degree angle, so this wall runs opposite this joist, if it runs at a perpendicular to the joist or the trusses, I assume it's bearing unless I know better. And then if it runs the same direction in parallel with roof trusses or joists, I will assume that it's a non-bearing wall. All right, that's the easiest way to assume. Otherwise, consult the drawings or the general contractor or a code official to determine whether or not it's a bearing wall. Okay, those are kind of your options there. So any wall that is perpendicular to the joist might be bearing. Any wall that is not is probably a non-bearing wall. Any short wall is usually a non-bearing wall. Generally, bearing walls will end up running almost the entire length of the structure. And if you get used to residential construction and even commercial construction for that matter, you can usually figure out what's bearing and what's not. But it's not something we can cover in this class in a reasonable amount of time. So if we have a stud, all right, we have two studs here. We have let's make them both 2x6s. 2x4s and 2x6s are going to be your most common stud size. As a matter of fact, we'll do a bearing 2x6. So let's make this one a bearing 2x6. All right, just as a example. And we will do a non-bearing 2x4. Alright, so we have a bearing wall and a non-bearing wall. And the rules are different between the bearing wall and the non-bearing wall. So the first thing we read out of this chapter is that exterior walls and partitions and bearing walls shall not be cut or notched in excess of 25% of its depth. So again, if we make a little notch right here in the wall, this cannot be more than 25%. So percent, and it bothers me that they do this, that they switch between percent and thirds and fractions, but 25%, so 1/4, right? So this cannot be more than 25%, which for a 2x6, all right, I'll make sure I'm right this time. Width of a 2x6. It sucks that stuff's not necessarily the same dimensions, but it is what it is. So a 2x6 is 5.5. All right. So a 2x6 is 5.5 inches. So we need to do 5.5 inches times 0.25, and that will give us our notch. Oh, and I did it the wrong way again. The notch, it's how deep it is, right? I'm just kind of writing on the longest side. So this can't be more than 25%. All right. And for a 2x6 bearing wall, all right, for a 2x6 bearing wall, that would be 1.375 inches, or exactly 1 3/8 inches. So that would be exactly 1 3/8 inches on a bearing 2x6. All right. So 25% of a notch of the depth. It can really be as long as you want it to be. It can be almost all the way down the wall by code. It's not a great idea, and the inspector might have some questions or want a steel plate to go down it, but there's technically no maximum length. It's just depth. Okay. And for non-bearing partitions, it can be not notched in excess of 40% of its depth. So on this one, on a non-bearing 2x4, all right, non-bearing 2x4, so this wall is smaller, so we're going to get different numbers than this one. But what I want you to do is practice the opposite of both these. So then practice a bearing 2x4 and practice a non-bearing 2x6. Okay, that'll give you good practice and see if you come up with the same answers. But in a bearing 2x4, we are no more than 40%. All right, so 40% of our depth. So on a 2x4, we'll do the math. A 2x4 is 3 5/8. So let me double check I write the right number here. 5/8 is 625. So 3.625 is a 2x4. So a 2x6 is 5.5 inches. As a matter of fact, let me write this. It's really 1.625. All right, 1 5/8 by 5.5 is the actual dimensions of a 2x6. And on a 2x4, it's 1.625, so 1 5/8 by 3.625, which is 3 5/8. All right. So that is the actual dimensions of both of these. So 3 5/8 times 0.4 means our notch cannot be more than 1.45 inches. All right, and that is our notches. And if this is confusing, I highly recommend you watch it again or ask me some questions on it. But make sure you understand these questions, these how you get these numbers, because they will be on your test. Alright, so non-bearing wall 40%. Oh no, yeah, non-bearing wall 40%, bearing wall 25%. That's notches. Alright, bored holes. Alright, bored holes. The diameter of bored holes in wood studs shall not exceed 40% of its depth. Alright, so they don't say anything about bearing or non-bearing here. They just say bored holes in wood studs shall not exceed 40%. But then they say the diameter of bored holes in wood studs shall not exceed 60% of the depth in non-bearing partitions. Alright, so non-bearing is 60% and everything else is 40%. The diameter of bored holes in wood studs shall not exceed 60% of the stud depth in any wall where each stud is doubled. We'll talk about that in a minute. Provided that no more than two such successive double studs are so bored. I really hate the way they word that, but that's the way they word it. And then the edge of the bored hole shall not be closer than 5/8 to the edge of the stud. Bored holes shall not be located in the same section of a stud as a cut or notch. So if we have notches in this stud, we can't put a hole here, right? We can't put holes in this area where it's notched. So our holes can't go there, all right? So if we want to make a hole, no matter what, we have to be at least 5/8 of an inch over from the edge of the stud, all right? No matter what, we have to be at least 5/8 of an inch away from the edge of the stud. If we're closer than 5/8 of an inch to the edge of the stud, then it will be considered a notch. So bored holes at least have to be 5/8 of an inch over. That's for all studs, so that'll apply to both. As a matter of fact, let me just copy this. Oh no, can I do it? Can I do it? It's such a small section to grab. There we go. We want this and this. Let's just copy it and paste it over here because the rules apply to both bearing and non-bearing partitions. Alright. For a bearing partition, this diameter cannot be more than 40%. So that 40% on a 5.5 inch 2x6 would be 5.5 times 0.4, and that's going to be 2.2 inches. Alright, so 2.2 inches. So basically really a little less than 2 1/4, 2 1/8, right? 2 1/8 of an inch on a 1x6 stud. Let me grab it right. Alright, and then on a non-bearing partition, it shall not be more than 60%. So if we go back to our non-bearing, right, this is no more than 60% on a non-bearing. So 3.625, right? 3.625 for a 2x4 non-bearing would be times 0.6 is 2.175 inches. So if this is a non-bearing stud 2x4, it could be 175. So basically, again, about 2 1/8, give or take, really close to 2 1/8 inches. So there. So that is non-bearing. Now, the next sentence. The diameter of a bored hole in a wood stud shall not exceed 60% of the stud depth in any wall where each stud is doubled, provided that not more than 2 successive doubled studs are so bored. So, if you're working on a bearing wall, let me make a little picture here, and I'm not going to save this, but I'm just going to show it to you. If we got a wall, right? This wall goes across. This wall goes across. Let me make sure you guys can see this. Yeah. So this wall goes across, this wall goes across. We're gonna, oh, no. Try this again. So we have studs down this wall. This is the top and bottom plate. And then we're gonna draw some studs here. If you need to drill a bigger hole in a 2x6 stud, alright, or whatever, you need to drill a hole that's bigger than 2.2 inches. You need a 2.5 inch hole. Well, first let's make sure 2.5 is not more than 60%. So 5.5 times 60% would give us 3.3 inches, right? So we can't drill a hole bigger than 2 1/8 in a bearing 2x6 partition, but we need a 2.5 inch hole. We can actually do this if we double the studs. So if we put another stud next to this stud, and we put another stud next to this stud, right? We double up the stud, then we can drill the bigger hole, but we can only do it through 2 studs. So if we need to go through a third stud at 2.5 inches on a 2x6, we can't do it, because we can only go through the 2. But it does let you double up a couple studs so that you can go through with a bigger hole if you have to. And that's pretty much only applicable on bearing partitions, obviously, but it is a way to get a bigger hole if you need it. You just need to understand that that's what you can do. So you can double up a stud, drill a bigger hole, but you can only double up to 2 studs in succession. The edge of the bored hole shall not, we already did that, so that's all that. So that's everything else. That is wood studs right there, right? So there's wood studs, there's a joist. That's what you really need to understand, because they're going to ask questions on it. I know that's long and drawn out, but that's what you need to understand out of that. Alright, engineered wood has to be done by a registered design professional or the manufacturer's recommendation. So I was talking about those engineered joists, the ones that is like a 2x2 on the top and bottom, and then it's a piece of plywood or OSB in between. Those things, you have to pull up the manufacturer's instructions for that particular product and read what they say. Pretty much those things are usually, you can't cut within an inch of the top or bottom of it, but you can basically cut out everything in between, as long as it's not too long. You got a lot of leeway on those things, but you have to read the manufacturer's instructions. They don't put that information in the code book. And then you cannot alter trusses. Alright, trusses. Truss members and components shall not be cut, drilled, notched, spliced, or otherwise altered in any way without written concurrence and approval of a registered design professional or an engineer, right? That's what registered design professional basically means. Unless the engineer or the architect tells you you can do something to the trusses, you never cut, notch, drill, or splice trusses, period. Alright, alterations result in the addition of loads to any member such as HVAC equipment and water heaters shall not be permitted without verification that the truss is capable of supporting such additional loading. So technically you can't put any equipment, they can't be your HVAC and equipment in the attic. You're supposed to make sure that the truss can handle the load of that equipment. So technically the architect should know exactly where that equipment's going to go before you put it in. You can't add equipment. Now, in my experience, this isn't really important. Trusses can usually handle that additional load, but it's good to know you're supposed to make sure, and it's something they could fail you for. They could say, did this truss get designed with the equipment being on it in mind? And if you don't know, you have to find out if it's okay. Alright, in steel framing, I wouldn't worry as much about 302.5. The cutting, notching, and boring of steel framing members have to comply with the following sections. And basically, structural steel has to be by an engineer. And then cold formed Flanges and lips of load-bearing cold-form steel framing members shall not be cut or notched. Holes and webs of load-bearing cold-form steel framing members shall be permitted along the center line of the web and the framing member and shall not exceed the dimensional limitations, penetration spacing, or minimum hole edge distance as prescribed by the registered design professional. Basically, load-bearing cold-form steel framing is still registered design professional, and then non-structural, so most of your metal stud walls are going to be non-structural. Okay, if it's a non-structural metal stud wall, your holes cannot exceed 1.5 inches in width or 4 inches in length and cannot be spaced less than 24 inches center to center from another hole. I've never seen this enforced. I don't know why this is in the code. This has never been enforced as far as I know. I don't know if I don't understand this section 100% or what, but what this tells me is in those metal studs, you can only have the holes in it that are basically already in it from the factory. Nobody's ever enforced this. People turn those studs into Swiss cheese all the time. So I don't know if this is actually supposed to be enforced, but in 20 years of construction, this part of the code's pretty much always been there as far as I know, and nobody's ever enforced that. It's kind of ridiculous. Plumbing would be impossible if they did it like that. Not to mention it doesn't give you any leeway based on the size of the wall, which is crazy to me. Anyway, it is what it is. That's what that code section says. All right, equipment and appliance location. This section is extremely important. Equipment and appliances shall be located as required by this section. Specific requirements elsewhere in this code and the conditions of the equipment and appliance listing. Hazardous locations. Appliances shall not be located in a hazardous location unless listed and approved for the specific installation. Fuel-fired appliances, this is important, shall not be located in or take combustion from any of the following rooms or spaces: sleeping rooms, bathrooms, toilet rooms, storage closets, and surgical rooms. This is something that I would expect them to ask a question on some of your tests. Depending on which version of the test you get, they will say something along the lines of a fuel-fired appliance cannot be located in or contain a combustion air from a sleeping room, or give you 3 other options or something like that. The fuel-fired appliances cannot be located in these rooms. The exception is that you can have direct vented appliances that contain all combustion air directly from the outdoors. So the direct vent appliance can be, a bedroom if they take combustion air from an outside. Solid fuel-fired appliances, provided that they have combustion air provided in accordance with manufacturer's instructions. And appliances installed in a dedicated enclosure in which all combustion air is taken directly from the outdoors in accordance with Chapter 7. Access to such enclosure shall be through a solid door, weather stripped in accordance with the exterior door air leakage requirements of the Energy Conservation Code and equipped with an approved self-closing device. So this is what you see a lot of times on garages that have equipment. If you have a garage and the equipment is located in a room off the side of the garage, A, that could be considered a storage closet, and B, a lot of your fuel codes don't allow those appliances to be located in a garage. Okay, because there's fuel, there's gas fumes in the garage. So since they can't be located in the garage, to make it not part of the garage or to make it not a storage closet, you basically put an outside style door on it. You put an outside style door on it that automatically closes if you let go, and that is weather stripped, so that basically you're making a weather tight room from the other room, and that's the idea. Alright, appliances cannot be installed in a location subject to mechanical damage. So if there's something that might hit the appliance or mess it up, you can't have it there. We'll get to inside of parking garages and stuff, but that's what they're trying to say. If it's somewhere where there's a good chance of something damaging it, it can't be there. Furnaces and boilers installed in closets or alcoves have to be listed for that installation. Most furnaces and boilers are listed for alcove installation, but they specifically do have to be listed for that. Appliances installed in indoor locations shall be listed and labeled. Installed in other than indoor locations shall be listed and labeled for outdoor installation. So the appliance has to be specifically made for being installed outdoors if it's going to be outdoors. Microphone keeps moving. All right. Pit locations. Appliances installed in pits or excavations. I would highlight all this if you're the highlighting type of person. Appliances installed in pits or excavations, all right, shall not come in direct contact with the surrounding soil. The sides of the pit or the excavation shall be held back not less than 12 inches from the appliance. Where the depth exceeds 12 inches, okay, below adjoining grade, the walls of the pit or excavation shall be lined with concrete or masonry. Such concrete or masonry shall extend not less than 4 inches above adjoining grade. All right. Anywhere where you've got numbers and stuff like this is a good thing they're probably going to ask questions on. So they may say, the sides of the pit or excavation shall be held back not less than blank inches from the appliances, and you'll have to find 12. All right. But if it's in a pit, the excavation has to be at least 12 inches from the appliance, and if the pit is more than 12 inches below grade, right, then it has to be lined with concrete or masonry, the walls of the pit. And the walls of the pit have to extend at least 4 inches above the grade around it. Mechanical systems shall not be located in an elevator shaft. This is pretty much everything. Nothing can be in an elevator shaft except for an elevator and sometimes a sump pump that is in the elevator pit. Section 304, installation. Equipment and appliances shall be installed as per their approval. Where conflicts between this code and the conditioning of the listing or manufacturer's instructions occur, the provisions of this code shall apply. So the code supersedes the manufacturer's instructions, right? But there's an exception where a code provision is less restrictive than the conditions of the listing of the equipment or the appliance or the manufacturer's installation instructions. The conditions of the listing and the manufacturer's installation instructions shall apply. So basically what they're really saying is whichever is more stringent, you have to follow. So if the code says this has to be 6 inches from the wall, and the manufacturer's instructions say it has to be 8 inches from the wall, well, then you have to be at least 8 inches from the wall because the manufacturer's instructions are more stringent than the code. All right? So whichever is more restrictive, you have to follow that thing. It used to just be that the manufacturer's instructions always took precedent, but then they added this exception at some point. So it's like, well, whatever's more restrictive. All right, this is important. Elevation above ignition source. Because we have a number here. Again, anytime you see a number in inches or something like that, it's probably something they'll ask a question on. All right, equipment and appliances having an ignition source. All right, and located in hazardous locations in public garages, private garages, repair garages, automotive motor fuel dispensing facilities, and parking garages shall be elevated such that the source of ignition is not less than 18 inches above the floor surface. All right. So any equipment in a garage or something has to be at least 18 inches above the floor surface. Again, because the fumes from the gases, gas tanks and things like that might ignite. For the purpose of this section, rooms or spaces that are not part of the living space of a dwelling unit and that communicate directly with a private garage through openings shall be considered part of the private garage. Remember I was saying, when that garage is right up, when your mechanical room is right inside the garage basically, if there's a door that opens to that room from the garage, then it's just considered part of the garage. So you have to meet this exception back up here where that you have a solid weather strip door so that we don't consider it part of the garage. Okay. Exception: the elevation of the ignition source is not required for appliances that are listed as flammable vapor ignition resistant. So that's when all that stuff started. The FVIR water heaters and things like that. That started because of this section of the code. So that's where those come in. All right. Parking garage. In connection of a parking garage with any room in which there is a fuel-fired appliance shall be by means of a vestibule providing a two-doorway separation, except that a single door is permitted where the sources of ignition in the appliance are elevated in accordance with section 304.3. This is a really interesting code section for me. I can't imagine you'll actually get a question about this on your test because this is kind of confusing. But it's a very interesting code section to me. I've always remembered this just because I thought that was interesting. That if an appliance is connected to a garage, it has to be a two-way doorway separation, or it has to be above the ignition source, or a parking garage rather. If you ever do any mechanical equipment in parking garages, you might want to understand that section very well. But basically, it just means that you have to go through a door, an empty room, and then another door. You can't just have the door straight to the mechanical room in a parking garage. Alright. Equipment and appliances having an ignition source shall not be installed in Group H occupancy. If you're doing a Group H occupancy, you're going to understand this anyway, okay? Because that's an occupancy where shit is hazardous, shit might blow up. So that's what that is. Hydrogen generating and refueling shit, we're not going to go through this. I would highly recommend that you probably highlight everywhere there's a number. And if you see anything about hydrogen generating and refueling operations, you look at this section. But we're not going to go through this in depth because it's not that important. Alright, well, I would highlight this. Louvers and grills in two openings. We're going to discuss how you do this stuff, and I'm sure this is all very similar to gas code stuff. We're going to go through this in another video, but this does give you a place where they talk about two permanent openings in louvers and grills, and all these requirements are very similar to the International Fuel Gas Code. So you might want to just know where that section is in case they ask about it. I would read that, but yeah. Anything out of there if they ask about hydrogen generating and refueling. Alright, public garages. Where appliances are located in public garages, motor fuel dispensing facilities, repair garages, or other areas frequented by motor vehicles shall be installed not less than 8 feet above the floor. So in public garages, appliances in public garages, or repair garages, or fuel dispensing facilities shall be not less than 8 feet above the floor. Where motor vehicles are capable of passing under appliance installed clearance by the manufacturer, not less than 1 foot higher than the tallest vehicle garage door opening. Alright, so you have to have the clearances required by the manufacturer, but the equipment has to be at least 1 foot higher than the tallest vehicle garage door opening. So basically, if a vehicle, if it says vehicle max 7'6" in the garage, then your appliance has to be at least 8'6". The exception is if it's protected in accordance with NFPA 30A. This is basically having bollards and stuff around it. Alright, that's what that is. But if you're protected another way, then they'll allow it. Oh crap. Sorry. So for part of that, obviously the words were off the screen, but it is what it is. We will continue. Alright, private garages. Appliances located in private garages and carports shall be installed with a minimum clearance of 6 feet above the floor. Alright. So that's basically, if it's in a private garage, hopefully your vehicle is not taller than 6 feet, but they just give you a solid 6 feet with private garages, whereas in public garages it's at least 1 foot above the opening. Boiler rooms and furnace rooms have to be protected in accordance with the building code, so there's certain requirements in the building code you have to follow. Clearances to combustible construction. This again is more like a fuel gas code thing. So if there's any manufacturer's instructions on required clearances to combustible construction, you'll need to follow those. But they talk more about combustible construction and appliance clearances in the fuel gas code, where it's more relevant because that covers specifically natural gas and propane appliances. All right, clearance from grade. This is an important one, right? Equipment and appliances installed at grade level shall be supported on a level concrete slab or other approved material extending not less than 3 inches above adjoining grade. So that's why we have pump ups, right? Or they have to be suspended not less than 6 inches above grade. So if you hang them off the wall, they have to be at least 6 inches above the ground. So heat pumps and air conditioners are supposed to be at least 3 inches above the ground. And then if it's suspended, it has to be at least 6 inches above the ground. It used to be that it was just heat pumps that required it because it was part of the manufacturer's instructions, but now it's everything. It has to be at least 3-inch pump ups or something. Really, your equipment pad, if it's sitting straight on the ground, adds to this, but people just generally use at least 3.5-inch pump ups no matter what. And some people use 6-inch pump ups because they think that this means it has to be a 6-inch pump up, but it doesn't. So that's where 6-inch pump ups came for. It's amazing how you can see where misinterpretation of the code leads to manufacturers creating shit. The reason there are 6-inch pump ups is because of this. I can almost guarantee it. Alright? Because people misinterpret code sections. It's amazing. I can find instances like this in lots of situations. Alright? This is not the only thing I can think of. But, it's the only one I can think of right now. But I see this all the time. You know, people, another good example would be I went to a supply house one time and I asked for flex duct with R6 insulation. And they said, we only have R8. Really? Yeah, because you can't have all Flex has to have at least R8 insulation. No, all Flex has to at least have R8 insulation in an attic. It doesn't matter what the insulation are, is if it's just in a plenum ceiling. But again, supply houses and manufacturers and stuff sometimes start creating things because people tell them stuff that's not true. You'd be surprised, okay? Not everybody actually understands things. Hopefully, by the time we're done, you'll actually understand them. Guards. Everything on guards is extremely important, alright? Guards shall be provided where various components that require service and roof hatch openings are located within 10 feet of a roof edge. So anytime you're within 10 feet of a roof edge, or open side of a walking surface, which we're going to get to in a second. But anytime you're within 10 feet of the roof edge is the most common one, you have to have guards, okay? Or open side of a walking surface and such edge or open side is located more than 30 inches above the floor, roof, or grade below. So if the equipment is sitting on a platform, this happens a lot with cooling towers, right? If you have a cooling tower and a platform, or up above grade, and then they build a platform around it to work on, you have to have guards, right? Anytime there's a walking surface more than 30 inches above the ground or on a roof, you have to have guards, all right? The guard shall extend not less than 30 inches beyond each end of a components that require service. So it has to be 30 inches past the component that requires service. The top of the guard shall be located not less than 42 inches above the elevated surface adjacent to the ground, and the guard shall be constructed so as to prevent the passage of a 21-inch diameter sphere. All right, so all those sentences are important. All those sentences are something that they might ask you questions on your test. All right. The exception is guards are not required where permanent fall arrest or restraint anchorage connector devices that comply with ANSI ASSE Z359.1 are fixed for use during the entire lifetime of the roof covering. So basically, if instead of guards, they can provide permanent anchor restraints so you can attach a harness. So if you can go up there and attach a harness to something before you walk towards the equipment, then you don't need the guards. This is just an easy way to get around this for really when it's in a stupid situation. Because there are situations where guards and walking surfaces are just impossible. So they'll put a permanent connection for a fall harness. All right, the devices have to be reevaluated for proper replacement when the entire roof covering is replaced, and the devices shall be placed not more than 10 feet on center along the hip edge and ridge lines, and not placed not less than 10 feet from the roof edges and open side of walking surfaces. So basically, they have to make it so you can safely get to the harness point, and that the harness point has to be permanently installed on the roof. Alright, appliances serving different areas of the building other than where they are installed shall be permanently marked with an approved manner. Alright, that uniquely identifies the appliance. So if the appliance serves a completely different side of the building, then you're supposed to permanently mark it on what it serves so that you know. Alright, piping support. These are pipe support requirements. Most pipe support requirements are going to be in accordance with manufacturer's instructions. If you do a lot of commercial work, you should be familiar with ANSI MSS SP 58. So if you do piping work, chiller work, boiler work, you'll want to know this code. You can generally find it in the specs of the job or something. But that's the interval of the support. Otherwise, you follow this. This is the code requirements on pipe support, so you want to know this section. So if you're installing copper pipe, right? Or no, sorry, forget that, because copper pipe is almost non-existent. If you're installing copper tubing, right, 1.25 inches or smaller, then, and this is not for refrigerant piping, because refrigerant piping I think has a special section on it, but I could be wrong. Alright, assuming there's not a special section where we get to refrigerants on refrigerant pipe would have to be supported every 6 feet or every 10 feet vertically, and so on and so forth. If you're installing any type of pipe, then here is the spacing requirements for every type of pipe. Alright, that they have in the code anyway. Anything else, manufacturer's instructions. And then there's some notes here. We won't go through those notes, but you should read them and understand them. Mainly it's just the cast iron thing and the mid-story guide. Mid-story guide just means you have to have one between the two floors. But anyway. Protection against physical damage in concealed locations where piping other than cast iron or steel. Alright, so any piping other than cast iron or steel is installed through holes or notches in studs, joists, rafters, or similar members less than 1.5 inches from the nearest edge of the member. The pipe has to be protected by shield plates. This is what you need kick plates for. So like your refrigerant piping, if it's going up through a wall or floor and it's within 1.5 inches of the edge, 1.5 inches of the edge of the wall or floor, you have to have a 16 gauge shield plate. Wherever it's the member is notched or bored and extends 2 inches above sole plates or below top plates. So that's the top or bottom. That's where you need a 5x8 kick plate. That's where you need kick plates. If your piping is within 1.5 inches of the edge of a stud, joist, or rafter, you have to have a kick plate. Alright, access and service space. Extremely important section, alright? Extremely important section. Appliances, control devices, heat exchangers, and HVAC system components that utilize energy shall be accessible for inspection, service, repair, or replacement without disabling the function of a fire resistance rated assembly or removing permanent construction, other appliances, venting systems, or any other piping or ducts not connected to the appliance being inspected, serviced, repaired, or replaced. Everybody likes to laugh at this section because a lot of existing buildings don't meet this section. To remove the air handler in the attic, you have to take apart the attic access. That's technically against code. Okay? It is. It's against code. But obviously, when it's existing or somebody does a repair or replacement and doesn't make sure that it meets these requirements, sometimes that doesn't happen. But that is code. Any new building should be made so that the equipment can be repaired, replaced, or serviced without removing any permanent building components. Alright, a level working space not less than 30 inches deep and 30 inches wide shall be provided in front of the control side to service the appliance. So in front of every appliance when you install it, you need to have a 30 inch by 30 inch square of available space so that you can work on that appliance. Central furnaces with components or alcoves shall have a minimum working clearance of 3 inches along the sides, back, and top with a total width being not less than 12 inches wider than the furnace. Furnaces having a firebox open to the atmosphere shall have not less than 6 inches working space along the front or combustion chamber side. Usually that side is the service side anyway, so it's going to be at least 30 inches clear space in front of it, but you have to keep at least 6 inches in front of the firebox. Alright, combustion air openings at the rear side of the compartment shall comply with the requirements of Chapter 7. This section does not apply to replacement appliances installed in existing compartments and alcoves where the working space clearances are in accordance with the equipment or manufacturer's installation instructions. Appliances in rooms. Rooms containing appliances shall be provided with a door and unobstructed passageway not less than 36 inches wide and 80 inches high. It has to be at least, if you're going to a room that has appliance, it has to have at least a 36-inch door. Alright? Or the door has to be big enough to take the appliance out if for some reason the appliance is bigger than 36 by 80. The exception is within a dwelling unit. Alright, so within a residential house, that's basically what dwelling unit means. Within a dwelling unit, appliances installed in a compartment, alcove, basement, or similar space shall be accessed by a door or unobstructed passageway not less than 24 inches wide and large enough to allow the removal of the largest appliance in the space, provided that a level service space of not less than 30 by 30 is provided in front of the appliance. So as long as you meet this section, it can be a 24-inch door that's at least tall enough to remove the appliance. Appliances in attics shall be provided with an opening and unobstructed passageway large enough to allow removal of the largest appliance. You're going to see that sentence a lot, alright? Large enough to allow the removal of the largest appliance. The passageway shall not be less than 30 inches high and 22 inches wide. So you have to have the passageway to get to the appliance. You have to have at least 30 inches high, clear, and 22 inches wide, clear. The passageway shall have continuous solid flooring not less than 24 inches wide. A level service space of not less than 30 by 30 has to be provided. Alright, at the service side of the appliance. Clear access opening dimensions have to be at least 20 by 30, so an attic access has to be at least 20 inches by 30 inches if there's an appliance in there, but large enough to allow removal of the largest appliance. The exceptions are passage and level service space are not required where the appliance is capable of being serviced and removed through the required opening. Alright, so this is a good exception. If you ever get busted for not having a big enough door or something, or a big enough service area, a big enough passageway, if you can service the equipment through the opening and you can get the appliance out through the opening, you don't have to meet those requirements. So that is a exception that comes in handy if you do residential. And where the passageway is unobstructed and not less than 6 feet high and 22 inches wide for its entire length, the passageway shall not be greater than 50 feet. So the passageway cannot be more than 20 feet long, right? 20 feet in length. But if you've got at least a 6 foot high, 22 inch wide passageway, you can extend that to 50 feet. So if for some reason your attic door is more than 20 feet from the appliance, you have to have a higher passageway, basically a hallway size passageway to get to the appliance. Electrical requirements: a luminaire controlled by a switch, so a light controlled by the switch at the required passageway opening, and a receptacle outlet shall be provided at or near the appliance in accordance with the National Electrical Code, NFPA 70. So your light switch has to be next to the attic opening or the crawl space opening, and you have to have an outlet close to the appliance. Alright? Light switch by the opening to get there, and a outlet near the appliance. Appliances under floors. Underfloor spaces containing appliances shall be provided with an access opening and unobstructed passageway large enough to allow the removal of the largest appliance, right? Same thing again. Passageway shall not be less than 30 inches high and 22 inches wide, nor more than 20 feet. So basically the same as attic so far, right? The level service space not less than 30 by 30. Again, If the passageway or service space extends, alright, so this is where it starts to get different from attics. If the depth of the passageway or the service space exceeds 12 inches below grade, the walls of the passageway shall be lined with concrete or masonry. So if you're in a crawl space that's basically a pit, then it has to be lined with concrete or masonry walls. Such concrete or masonry shall extend not less than 4 inches above adjoining grade, and the clear access opening dimensions shall be not less than 22 by 30, or large enough to allow removal of the largest appliance. All right. The passageway, same thing, same exceptions basically. All right, the exact same exceptions. The only difference is the exception here. The passageway is not limited in a crawl space if it's more than 6 feet by 22 inches wide, whereas with the attic it's still less than 50 feet. So there's a slight difference in the exception there. Same thing for electrical requirements. It's the same as attics. Okay, on roofs and elevated structures, where the equipment or appliance is located on an elevated structure or roof of a building such that personnel will have to climb greater than 16 feet above grade to access the equipment or appliances, an interior or exterior means of access shall be provided. So anytime it's higher than 16 feet, you have to have a permanent ladder somewhere, inside or outside. Such access shall not require climbing over obstructions greater than 30 inches in height. Alright, so you can't have to climb over anything greater than 30 inches in height, or walking on roofs having a greater slope than 4 inches vertical and 12 units horizontal, or 33% slope. You can't have to work on equipment on a roof that has more than a 33% slope. If it does, then they'll have to build catwalks for it. Such access shall not require the use of portable ladders. Again, it has to be a permanent ladder or permanent access if it's more than 16 foot to the roof. Where access involves climbing over parapet walls, the height shall be measured to the top of the parapet wall. Permanent ladders installed to provide require access shall meet the following criteria. Alright, the side railing shall extend above the parapet by not less than 30 inches, parapet or roof edge. The ladder shall have rung spacing not to exceed 14 inches on center. The uppermost rung shall not be greater than 24 inches below the upper edge of the roof hatch or parapet where applicable. Go ahead and highlight that 24 in case you see the rest. Ladder shall have a toe spacing of not less than 6 inches deep. There shall not be less than 18 inches between the rails. The rung shall have a diameter of not less than 3/4 of an inch and be able to withstand a 300-pound load. Ladders over 30 feet in height shall be provided with offset sections in landings capable of withstanding 100 pounds per square foot. So if the ladder is more than 30 feet high, they have to have a little landing where you can rest every 30 feet. And a guardrail has to be provided on all open sides of the landing. Alright, climbing clearance. The distance between the center line of the rungs to the nearest permanent object on the climbing side of the ladder shall not be less than 30 inches measured perpendicular to the rungs. So you have to have a 30-inch clear space where the ladder is at all the way up. Alright, so 30-inch distance from center line of the rungs to the nearest permanent object shall be not less than 30 inches. Alright, the distance shall be maintained from the point of ladder access to the bottom of the roof or hatch. Minimum clear width of 15 inches shall be provided on both sides of the ladder as measured from the midpoint to parallel with the rungs. Alright, just basically 30 inches clear space all the way up. The ladder shall be provided with a clear and unobstructed bottom landing area having a minimum dimension of 30 by 30. So again, 30 by 30. Ladders shall be protected against corrosion by an approved means, and access to ladders shall be provided at all times. Alright? It's important to understand all these ladder requirements. They are in the mechanical code. There will be questions on them. Catwalks installed to provide access shall be not less than 24 inches wide and shall have railings as required. This section does not apply to Group R3 occupancies, which I believe is single-family homes. I can't remember for sure. You want to double-check the building code on that. R2 or R3, I believe, is single-family homes, but I think it's R3. Alright, sloped roofs, where appliances, equipment, or other components that require service on a roof having a slope of greater than 3 units vertical and 12 units horizontal. All right, so 25% slope or greater, and having an edge more than 30 inches above grade. At such edge, a level platform shall be required for the appliance. So they have to build a catwalk to work on the appliance if the roof has more than a 25% slope. The platform has to be not less than 30 inches in any dimension and shall be provided with guards. We already read the guard section, right? The guard shall not extend less than 42 inches above the platform and shall prevent the passage of a 21-inch diameter sphere, basically repeating everything from the section on guards. Access shall not require walking on roofs having a slope greater than 4 units and 12 units horizontal or a 33% slope. So to get to the unit, you can walk on a roof that has a 33% slope, but at the unit it has to have less than a 25% slope, where you have to have a platform to work on it. Where access involves obstructions greater than 30 inches in height, such obstructions shall be provided with ladders in accordance with section 306.5 or stairwells in accordance with the requirements of the building code. Alright, so that is sloped roofs. Same electrical requirements, outlet near the equipment. Condensate disposal. Condensate disposal is important. Yeah, let's just read through it. All right, fuel burning appliances. If the fuel burning appliance has condensate, it shall be discharged to an approved plumbing fixture in accordance with the manufacturer's instructions. In our area, generally it has to go outside or to a storm drain, but in some buildings they'll let you go to the sewer. But a lot of areas don't want you taking condensate to the sewer. All right, because it's clear water waste. So for Virginia, be careful going to a sewer unless it's allowed. Condensate piping has to be made of a corrosion resistant material and shall not be smaller than the drain connection on the appliance. The pipe of the drain has to slope in the direction of discharge at least 1/8 inch unit and 12 units horizontal. All condensate has to slope at least an 1/8 inch per foot. Always with everything. Condensate is always an 1/8 inch per foot. For evaporators and cooling coils, in accordance with the manufacturer's instructions. The exception is sensible cooling only appliances. That's going to be really rare. There's almost nothing that's sensible cooling only. I think the only exception is chilled beams or something. But if something doesn't need a condensate drain, you'll know it because the manufacturer won't tell you need a condensate drain. And almost every piece of equipment needs a condensate drain. Again, condensate disposal has to go somewhere that's approved by the jurisdiction, basically. And it's, again, not less than an 1/8 inch per foot grade. Condensate shall not discharge into a street, alley, or other area that it might cause a nuisance in. Okay, so you can't just run condensate right into the middle of the street. All right, you can't just take it to an alley. You can't just take it to a walkway or somewhere where it's going to cause a nuisance. You have to take condensate somewhere where nobody's going to be bugged by it. Yeah, that's literally in the code, so it's something to keep in mind. All right, drain pipe materials can be cast iron, galvanized steel, copper, PEX, ABS, PVC, CPVC, or polypropylene pipe or tubing. There's your options on types of pipe. They have to be selected for the temperature and pressure rating of the installation in accordance with the International Building Code. Condensate and waste drain lines shall not be less than 3/4 inch internal diameter and shall not decrease in size from the drain pan connection to the place of condensate disposal. This is very interesting. Not less than 3/4 inch internal diameter, because that basically means if you're using something like PEX, okay, or CPVC, that would be at least a 1-inch PEX or CPVC pipe, okay, because they are commonly smaller on the inside than regular pipe. So they're made at copper tube sizes, so they're generally smaller than that. That is something to understand. I've never seen anybody dinged on it, but technically if you're using CPVC or PEX, you have to go to 1-inch pipe. You can't use 3/4. All right, and then condensate drain sizing. This table is really handy. All right, if you need to know how big a condensate drain needs to be based on tons, of your refrigeration that you have, that's the table. So up to 20 tons is 3/4, 20 to 40 is 1, 40 to 90 tons is 1.25 inches, 90 to 125 is 1.5 inches, and 125 to 250 is 2 inch. So it has to be at least the size of the drain pan connection, but this, otherwise you can size it based on this. They added this in 2012, I think, so that was a really helpful. Before that, it had to be based on an engineered drawing, basically. You had to get an engineer to tell you what size your condensate pipe used to have to be, but then they added this table. All right, extremely important section again, auxiliary and secondary drain systems. All right, so I'm going to explain why you need an easy trap, basically, or why you don't need an easy trap, even though you think you always need one. All right, in addition to the requirements of 307.2.1, where damage to any building component could occur as a result of overflow. Oh, did I hit record? Yeah, I did. Where damage to any building components could occur as a result of overflow from the equipment primary condensate removal system, one of the following auxiliary protection methods shall be provided for each cooling coil or fuel-fired appliance that produces condensate. An auxiliary, so if you have a condensate drain, and if the condensate drain backs up, the equipment will damage a part of the building. So if it's on an attic and it's going to mess up the ceiling, or it's in a basement where there's no drain and it's going to mess up the floor or the walls or anything, if the equipment were to overflow and it would cause damage to the building. So in other words, if it would overflow and there's no floor drain right nearby on an impervious floor, you have to provide one of these methods. Okay, you have to pick one of these methods to protect it from damaging the building. Okay, you don't have to do all of them, you just have to pick one. So your options are 1, 2, 3, or 4. Option 1 is an auxiliary drain pan with a separate drain. So you can have an extra drain pan underneath the unit with a separate drain to it. And if that's what you do, it has to meet these requirements. All right, so an auxiliary drain pan with a separate drain. The auxiliary pan drain shall discharge to a conspicuous point of disposal to alert occupants in the event of stoppage of the primary drain. So that secondary drain pan in the attic, right? That's supposed to, the drain off of it is supposed to go somewhere where somebody's going to notice the water coming out. So 9 times out of 10, it should not be going right next to your other drain. It should go like next to the front door or something, somewhere where the homeowner will recognize, oh, that usually doesn't have water coming out of it. Why is there water coming out of it? Maybe I should call somebody. It's supposed to be to a conspicuous point of disposal that will alert the occupants that there's a stoppage in the primary drain. Alright, the pan shall have a minimum depth of 1.5 inches and shall not be less than 3 inches larger than the unit, or the coil dimensions in width and length, and shall be constructed of a corrosion-resistant material. Galvanized steel pans have to be at least 24 gauge, and non-metallic pans have to be at least 0.0625 inches thick, or 1.6 millimeters. That would be a 32nd of an inch, maybe? 0.0625. I think that's 32nd, or no, that's a 16th. Has to be at least a 16th of an inch thick. Whatever. Pans are generally going to meet those requirements. You usually don't have to figure that out, but if you get the pan made at a sheet metal shop, it has to be at least 24 gauge metal. Not 26, 24 gauge. So you can get popped on that if you're not careful. A lot of people just get them in 26. Alright, a separate overflow drain shall be connected to the pan provided equipment. So you can provide, you can connect to that secondary drain on the equipment and run 2 separate drains to the outside. Such overflow drain shall discharge to a conspicuous point of disposal to alert occupants, alright, in the event of a stoppage. So, that secondary drain connection, you can use that. Or you can do it in an auxiliary drain pan without a separate drain line that is provided under the coils in which condensate will occur. Such pan will be equipped with a water level detection device conforming with UL 508 that will shut off the equipment served prior to overflow of the pan. The auxiliary drain pan shall be constructed in accordance with item 1. So instead of a pan with a drain, you can have a pan with an overflow switch. And the last thing you can have is your Easy Trap, a water level detection device conforming to UL 508 that shuts off the equipment in the event that the primary drain is blocked. Alright, the device shall be installed in the primary drain line, the overflow drain line, or the equipment supplied drain pan located at a point higher than the primary drain line connection and below the overflow rim of such pan. Alright, so your 4 options to protect the equipment from condensate overflow are an auxiliary pan, a secondary pan with a separate drain, a separate overflow drain line connected straight to the equipment, an auxiliary pan with a float switch, or an Easy Trap or other float switch in the primary pan or the primary drain line. Alright, the exception is fuel-fired appliances that automatically shut down operation in the event of a stoppage. So if there's already some kind of safety system inside the appliance, you don't need another safety system. On downflow units or all other coils that do not have a secondary drain or provisions to install a secondary drain or auxiliary pan, a water level monitoring device can be installed inside the primary drain. If you've got an equipment with a secondary, with a safety switch already installed in it, that's basically what this section says. Appliance equipment and installation in pans. Where appliance equipment or installation are subject to water damage when the auxiliary drain pan fills, that portion of the appliance equipment or installation shall be installed above the rim of the pan. Supports located inside the pan to support the appliance shall be water resistant and approved. So, you're not supposed to take your air handler and just put it right inside the drain. You're supposed to elevate it so it's not sitting in the drain pan, because there's insulation in there that'll get damaged, right? So you're not supposed to just put the equipment in the pan, because pretty much this applies to almost everything. Alright, traps. Condensate traps shall be trapped as required by the equipment or appliance manufacturer. When do you have to have a condensate trap? When the manufacturer tells you you have to have a condensate trap. Ductless mini-split systems traps. Ductless mini-split equipment that produces condensate shall be provided with an inline check valve located in the drain line or a trap. So if the mini-split requires a trap, you have to put in a trap. If it has a check valve in it, then you don't have to have a trap. Drain line maintenance. Condensate drains shall be configured to permit the cleaning of blockages or perform maintenance without requiring the drain line to be cut. You need to provide some kind of clean out or something. Or you have to have access to the end of the drain so you can clear blockage without cutting the line. Condensate pumps located in uninhabitable spaces such as attics or crawl spaces shall be connected to the appliance or equipment served such that when the pump fails, the appliance or equipment will be prevented from operating. Pumps shall be installed in accordance with the manufacturer's instructions. You have to hook up the safety circuit of the condensate pump. You can't just leave it disconnected. This is clearance reduction stuff. On clearances to combustibles and things like that. Alright, all this stuff, clearance reduction methods, basically just follow the manufacturer's instructions. There shouldn't be if any questions on your test about this, so we're not going to go through it in detail. But this is how you do clearance reduction of combustibles. Again, it's not a big deal. You need to follow manufacturer's instructions or follow the venting requirements of the fuel gas code. So most of this stuff is really fuel gas code stuff, so I'll talk about it on fuel gas code stuff, vent clearance reductions and things like that. But basically follow manufacturer's instructions. If you can't get required clearance to combustibles, know where this table is and read it and understand it. But if you can't read and understand this table, don't do clearance reduction methods. Alright. Temperature control, space heating systems. Interior spaces intended for human occupancies shall be provided with active or passive space heating systems capable of maintaining a temperature of not less than 68 degrees at a point above 3 foot above the floor on the design heating day. All right. The installation of portable space heaters shall not be used to achieve compliance with this section. Your furnace system has to be able to maintain a temperature of 68 at a point 3 feet above the floor on a design heating day. So, if in our area in Fairfax County that's 17 degrees, if on a 17-degree day the system can't get the temperature above 67, then you're in violation of the code. You didn't size the system properly. That's basically what that boils down to. I think this is really here for landlords. If landlords don't have heating systems that work, I think this just gives people the ability to sue, basically. I think that's really what this is here for. I could be wrong, but that's that. Explosion control, you have to make sure equipment's not going to blow shit up. Smoke and heat vents are in accordance with the fire code. Heating and cooling calculations have to be done in accordance with the ASHRAE ACA Standard 183, alright, and in accordance with using the design parameters of the Energy Conservation Code. This does not apply to residential, this applies to commercial. And that is Chapter 3. Next we will do Chapter 4. But that's all the most important sections of Chapter 3.